Hello everyone, welcome to Machine Learning with KNN Classification. Today we will show how to build a classification model using one of the most intuitive algorithms, K-nearest neighbor or KNN. In this video, we will explain how to code a machine learning model and also explain how it actually thinks, makes decision. We will use Python code and one of the simple dataset called iris flower dataset. So let's dive in. First, let's import all the libraries we need. Don't worry if you have not seen this before, we will explain as we go. We import the scikit-learn for our machine learning tools, pandas for our data manipulation, matplotlib, and seaborn for creating visualizations. These are the core tools that many data scientists use every day. We then load the dataset. This dataset is known as iris dataset. It contains around 150 iris flowers across three different species. And we have 150 samples as we can see here, and it has four features and three classes. These features are the length and the width of both sepals and the petals of the flower. Think of sepals as the green leaf-like part of the flower bud. And here are first five samples of the dataset as we can see. It has a sepal length, sepal width, petal width, and the species name. And this species is a mapping of species name. And we can also use pandas describe functionality to describe this dataset, which gives us the count of the dataset, the mean, standard deviation, and other information about the dataset. And as we can see, the dataset is equally distributed across three different classes. Um, and once we have looked at this, once we have gotten some understanding of the dataset and we know the dataset is balanced, we can get started with building some classifier. Before we do that, let's move to dataset visualization. Before we build any model, it's usually important to understand the dataset. So let's create some visualization to understand what kind of patterns exist. And we use Seaborn and Matplotlib in this case to plot the data set. We create a scatter plot of the data of the sepal length and the sepal width of the data set, and we can see that here. And once we look at the scatter plot, we can see that there are three different species of three different colors, and we notice that the setosa flowers, which are in blue color, form their own distinct cluster. So they're clearly different from the two other species. And let's look at the second plot, which plots the petal length versus petal width. And that also clearly indicates that there is clear distinction between the classes. And usually these kind of plots, which we can do using scatter plot or feature distribution, can help us understand about the data. In this case, the data set is simple, but often in real world there are complex data sets, but a simple data plots can help us understand how the data is distributed before we're moving on to building machine learning models. And we also look at the correlation matrix at this last plot. This feature correlation matrix shows us the petal length and the petal width are strongly correlated, so they tend to increase together. And this makes biological sense, and we can use some of this understanding to build our model. Then we move on to building our data set, which we can feed to the ML model. We first split our data into X and Y as this is a supervised model. And we're going to split our data set into two parts, 80% per our training, 20% per our testing. And we will use that testing to see how the model performs on unseen data set. This is crucial. We never let a model see the test data during training. And we were going to create X and Y for this. Since it's a supervised model, we split the dataset using train underscore test underscore split function from scikit-learn, which gives us the X train, X test, Y train, and Y test. And we are using test site as 0.2, which is 20%. And once we have that, we can look at like the trainings number of training samples and number of testing samples, and we can also look at the class distribution in the training and testing set. And one thing to note here is that we are using stratify, which ensures that the class proportion of each species in our training set and test set are usually equally distributed, and this is a good practice. Once we have that, we can move to creating a model. And creating a model using scikit-learn functionality is quite easy. We mainly import the k-nearest neighbor class here. Once we have that, we can define some of the parameters of the model, like we define the number of neighbors as 3, and that gives us a KNN classifier. We fit that model using fit function of the KNN class using our X train and Y train. And the X train and Y train are coming from here where we have split the data set to create X train and Y train. And once we have that, we can use that to predict on the test data set. So we use predict function from the scikit-learn functionality to predict on the test X data set. And that will give us Y-pred. And we can use the Y-test and Y-pred to get us an accuracy, and we can check if the model is good or not. And in this case, we can see the model is 100% accurate, which is a very great sign. In real world, this might not be always the case, but anything greater than zero point 0.9 or zero point 0.8 would give us a good model. And we can also get a detailed classification report from this dataset, and we can use the classification report functionality from scikit-learn where we pass the y-test and y-pred, and we also pass the target names, which gives us a little bit more uh, readable understanding of the classification report, and we get the precision recall, F1 score, and the support for this. We can also show some of the actual predictions, and thus in this case we can see the actual is Setosa, the predicted class is Setosa, and this is usually good practice to do for real world data sets so that we can truly understand what is going on when we train a model and we evaluate it on a held out set. And finally, we create a confusion matrix. And in this case, since it's a classification problem, the confusion matrix will show us how well the model is doing. And the confusion matrix shows us that like the model is perfectly accurate with 100% accuracy since it is predicting for the same class correctly. And the training for k-nearest neighbor is quite instant. Since k-nearest neighbor is a lazy learner, it does not need to actually build a model during training. It just stores all the training data and waits for until the prediction to do the work. And once we have this, we have already experimented, we know our model works, and then we can save this model for real world application and use this model to predict and run inference. And this is a quick example how we can build a machine learning model and use this model for real world inference. In many other following videos, we'll explore different machine learning algorithms. So stay tuned. Thank you.